Sup you all. Okay, I'm back again. Okay. Now we are gonna do laws of exponents. I'm gonna explain the laws of exponents. Then we are gonna do examples of laws of exponents. They are not exam questions, but they are examples. I'm gonna do examinable questions tomorrow. Okay, let's start. The first, we have 9 laws of exponents, but for now we are gonna focus on the six laws of exponents, since the questions that you're gonna do are gonna be under those 6 laws of exponents. Okay, the first one, it is saying a same basis we add the exponents. Okay, this thing, it is called the base. This thing is called the power or the exponent. So when you have something like a to the power of m multiplied by a to the power of n, you add the powers. When you have same basis, you add the powers. That is why they said 2 to the power of 4 times 2 to the power of 2 to the power of 4 times 2 to the power of 2. 2 to the power of 2 times 2 to the power of 4. It is the same as 2 to the power of 2 plus 4. That is 2 to the power of 6 when you just write it in a simplest form. So when you multiply, same basis, you add the powers, or sometimes they can give you sometimes they can give you, like, they will not say times, they will just write a dot like this, you see. Then they will say solve for it. So this dot means to multiply. Again, we have another law of dividing. Same thing, same basis, but this time you are subtracting. So when you have same basis dividing, you are now subtracting powers. So for instance, we have 2 to the power of 7 divided by 2 to the power of 5. So what do? You just write that one base, because the same basis. You are gonna write one base, so you're gonna subtract the powers. 7 minus 5, which is equals to 2 to the power of 2. Okay. Number 3 is saying a to the power of m times the power times n, so when you have something like that, it means that you multiply the powers only. You don't multiply by a, but you multiply by the powers. So it will be a to the power of m times n, you see. So that a doesn't change, it stays like that. So when you just multiply the powers only, for instance, we have 2 to the power of 3 multiplied by multiply by 4. So they did the same as 2 to the power of 3 times 4, which is 2 to the power of 12. So when you have when they gave you a base and two exponents, you multiply those two exponents so that you can get the number. So we come here again. So they give us two bases and one exponent. So when they give us two bases and one exponent, you must split them. How can you split them? You just write it as, like, for instance, ab times exponent n. You can write a to the power of n times b to the power of n. So you just split it like that. Another one, it is 2 to the power of 2x to the power of 2x squared. So when you split it, it will be 2 to the power of 2 multiplied by x squared, you see, which is 4x squared. 2 times 2 to the power of 2, it is 4, then x squared. So 2 to the power of 2 multiplied by x squared, it is 4x squared. And you see this dot, I told you earlier about this dot, that it also represents multiplication on the exponents. Okay, let's go to the other one, where you are splitting division. If you have a over something like a over b multiplied by the exponent of n, you can split it by writing a to the power of n over b to the power of n. It means that the n applies for all of the bases, you see. So let's go to number 5. Number 5, it is saying any base to the power of 0 gives us 1. So even if you can say 100 to the power of 0, it will still give you 1. Any base to the power of 0 gives you 1. 10 to the power of 0, it is 1. And sometimes they can give you questions like 1 is equals to 4. 1 is equals to 4 to the power of y. So when you can solve, like let me just say 1 it is equals to 2 to the power of y. They are saying solve for y, so you can simply take 1 and write it as 2 to the power of 0, because you know with anything to the power of 0 it is 1. So you are just reversing, you are just vice versa. So we are done. Oh, let's go to number 6. Number 6 is saying a to the power of negative m. It is the same as 1 over am, 1 over a to the power of m. So this one you're just writing it like this. You change the negative the negative uh, uh, the negative value there to positive value. You see, so when you're gonna write it, you're gonna say 1 over a to the power of m. When you write something like this, 2 to the power of negative 3, it is the same as 1 over 2 to the power of 3. The sign changes. You see, the sign changes. And this one, 2 to the power of 3, it is the same as 8. So it will be the same as 1 over 8. You see? Okay, let's check some questions. Let's check some questions. Check this question. It is saying 4 to the power of y is equals to 1. These are grade 11 exponential questions. So they are saying 4 to the power of y is equals to 1. So let's solve it. 4 to the power of y, it is equals to 1. The first thing that you must do, it is to take the number given to its simplest value. When you are taking the number to its simplest value, simply take the calculator and write that number, which is 4, then say equal sign, then say shift, then check this dots of fact. You see, you factor them to their simplest value, which is 2 to the power of 2. So you're gonna write 2 to the power of 2 multiplied by y equals to 1. This takes us back to the law number 3, which states that a to the power of m multiplied by another exponent. So we know when you have something like this, you multiply the bases only, which will be 2 times y, it is 2y. It is equals to here it is our challenge. Now we want to solve for y. How can we do that? Now we have 1, but I told you earlier that anything to the power of 0, it is 1. So now we can do vice versa by saying 2 to the power of 0. Then we know what anything to the power of 0, it is 1. So now we are now just moving from 1 to the maybe typical questions in J. Then you know with the same basis we cancel, so it will be left with 2y equals to 0. You know when you want to solve, you divide with the number that has a coefficient of y, which will be divided by 2. Then 2 cancel 2, then y is equals to 0. 0 divided by 2, it is 0. So your y will be equals to 0. Same basis, you cancel. When you have something like this, you can change this to the number that like the given base, so that you can make same basis. You see? Okay, let's go to number 2. Number 2, it is saying 25. Number B, it is saying 25x, it is equals to 1 over 625. You see? Let's solve it. (25x) equals to 1 over 625. As I told you earlier, every time you're solving this thing, you must take your numbers to its simplest value. So let's check. 25 is equals to shift those dots, which is 5 to the power of 2. 5 to the power of 2, everything multiplied by x, it is equals to. So now let's go back to our to the law number 6. Law number 6 states that anything to the power of a negative value can be changed to 1 over that base to the exponent of that positive value, that value, but now it is positive. So now I can change this 625 to 625 negative 1. You see? Then manje I can multiply 2 times x, which will be 5 to the power of 2x. Then 625 negative 1 can be written as this. Take 625 to its simplest value, which is 625, which is 5 to the power of 4. But now we are going to say 5 to the power of negative 4 because it was a fraction, you see. So now what do we have? Same basis. What do we do? Same basis, we cancel, which is 2x. It is equals to negative 4. Manje, what do? We want to solve for x. You know, when you want to solve for x, you divide by the number that you check the number which is the coefficient of x. Which number is the coefficient of x? It is 2. So you're going to divide everything by 2. X, it is equals to negative 2. Negative 4 divided by 2, it is negative 2. Everyone? So let's go to number 3. Number 3, it is saying that 16 to the power of 16 to the power of p is equals to 1 over 8. 16 to the power of p is equals to 1 over 8. You see, this one, it is the very ziyafana. We are gonna make longer steps because we are just doing notes. Step number 1, take everything to its simplest value. Let's take 16 to its simplest value. It is 2 to the power 4. It will be 2 to the power 4. Everything multiplied by p, which is equals to 8 negative 1. Okay, let's go reverse. Okay, it will be 2 to the power of 4p. We know what the exponents multiply each other, so it will be equals to let's go take a to its simplest value, which is 2 to the power of 3, but now it was a fraction, so it will be 2 to the power of negative 3. What do? We have this thing, okay, cancel, you see. So it will be 4p, it is equals to negative 3. Negative 3. So you see, we are doing same things, same basis, they cancel, so you are gonna say you are gonna divide everything by 4, because 4, it is the coefficient of p. So p, it is equals to negative 3 over 4. Please don't change to fractions. School maths, we are not doing don't change to decimals. School maths, we are not dealing with decimals. Please, let's go to number 4. When you get your answer like this, just leave it as it is. As you can see, negative 3 over 4. It is still the same thing. Don't do this. No, you are wrong. Okay, let's go to the other question. Question number D. 32 to the power of x, it is equals to 4. Wait, sorry. 32 to the power of z. It is z, ne? Yeah, it is z. So let's do it. 32 to the power of z is equals to 4. So do the very same thing. Take 32 to its simplest value. It is 2 to the power of 5. So it will be 2 to the power of 5. Everything times z is equals to, when you take 4 to its simplest value, it is 2 to the power of 2. So let's go. It will be 2 to the power of 5 z is equals to 2 to the power of 2. So now you check, same basis, they cancel, so it will be cancel. So it will be 5 z is equals to 2. We divide everything by 5. Then our z, it is equals to 2 over 5. I think from the previous questions, the last 3 questions, I was just saying the very same thing. So cancel, then our z will be over 2 over 5. Don't change to decimals, please. I beg you, please, don't change to decimals to avoid what is failure. Please don't do that. Okay, let's go to the other question. This one, manje, it is not like the other ones. It is now different. Let's check it. It is saying 5 multiplied by 25 to the power of d, it is equals to 3125. Okay, it is tricky, but you can solve it like this. 5 multiplied by 25 to the power of d, it is equals to 3125. Ne? So what can we do here? Let's just remove this 5 by dividing everything by 5. Ne? Okay, let's divide everything by 5 so that we know what this 5 cancel this 5, so that we know what will be left with 25 to the power of d. It is equals to 3125 divided by 5. 3125 divided by 5, it is 625. So it will be 625. Let's take everything to its simplest value. We know what is 25, it is 5 squared. Everything times d, it is equals to 625. We know what it is 5 to the power 5 to the power 4, not negative 4. It is not a fraction, so we know what it will be 5 to the power of 2 d. It is equals to 5 to the power 4. Same basis, they cancel, so 2 d, it is equals to 4. We divide everything by 2, therefore d, it is equals to 2. Did you understand? When you have a question like this and you can't solve it, you just simply remove this thing by dividing everything by this number. So you know what we are left with the simplest numbers. Then you take this thing to its simplest value, and take this other one to its simplest value. Then you solve it. Then you know what same basis they cancel. Then you solve it, guys. Then you have your value. Let's check another ones. Here is another one which is saying 25 x minus 2 multiplied by 5x minus 1, it is equals to 1. Let's go back to our first law of exponent, which is saying same basis they add. But now we have 25 and 5. So what can we do here? We can take anything to their simplest value. We can simply say, what is 25 to its simplest value? It is 5 squared. So it will be 5 squared multiplied by x minus 2 multiplied by 5x minus 1. 5 doesn't have its simplest value, so it will stay like that. It's equals to 1. When we multiply it to this, it will be 5 to the power of 2x minus 4. 2 times x, it is 2x. 2 times negative 2, it is negative 4. A positive and a negative, it is a negative, so 2 times 2, it is 4. Multiply by 5 to the power of x minus 1 is equals to 1. Let's solve now. Let's solve. So now let's go back here. They said same basis they add. So what can we do here? When you're multiplying same basis, you're gonna say 2x minus 4 plus x minus 1 is equals to, okay, since you know what this is 1, you can write it as 5 to the power of 0. 5 to the power of 0 equate to 1, so you are just doing vice versa. So you know what let's add 2x plus x, it is 3, so it will be 3x, then negative 4, negative 1, negative 4, negative 1, it is negative 5. So it will be 5 to the power of 3x minus 5, it is equals to 5 to the power of 0. So let's check same basis. What, sorry, let me write it carefully. 5 to the power of 0, same basis they cancel, so it will be 3x minus 5 is equals to 0. Let's just simply do it like this. 3x equals to 5. You must take 5 to the other side so that you can solve it, guys. We divide everything by the number with the coefficient of x, then you know what to x is equal to 5 over 3. When you have something like the first thing that you must do, exponents, take everything to its simplest value, the number that can be equated to its simplest value. When you are done, check check the sign. If the sign it is multiplying, take everything to its simplest value, make sure you have same basis, then you can multiply the same basis and add the same powers, so that you can add powers. If you have one on the other side, you want to make everything to have same basis, take that one and change it to the given number so that it can be same basis, then you can solve it, guys. You know, same basis they cancel, then you solve it, guys. Let me look for another one. Here is it, another one, which is 9 to the power of c times 3 to the power of c plus 2 is equals to 1. I know what manje I have to take everything to their simplest value. It will be 3 to the power of 2 multiplied by c times 3 to the power of c plus 2 is equals to 1. Then 3, then it will be 3, 2 times 8 is 2c times 3 to the power of 6 plus 2 is equals to 1. Okay, then I know with the same basis I must add the exponent, which will be like 3 2c plus c plus 2 squares 2 3 to the power of 0 1 to 3, they are the same. So I'm gonna say 3 2c plus c, it is 3c plus 2, so it will be equals to 3 to the power of 0. Same basis, they cancel, so it will be 3c plus 2 squares 2 0. So I'm gonna take 2 to the other side, so that it will be 3c, it is equals to negative 2. I divide everything with the number that is the coefficient of x, which is c, it is equals to negative 2 over 3. You see, here is it. Check your sign, check your basis, check your number that can be divided, that can be taken to its simplest value. You see, yeah. Then I'll do another one whereby you have to check what's common and do the fractions one. So manji, you know what's going on. So the next video I'm gonna do whereby you have to check what's common and multiply with the numbers and divide and get the value of x. And I'm gonna show you on the fractions, and I'm gonna do more of the exponents. Then we're gonna move on to another things, but so far you know how to deal with exponents. So continue subscribing. Thank you.